Here we go. We're talking about adding polynomials now. So the idea behind adding polynomials is that you want to have the same degree terms lined up, or really you're going to be adding the same degree. Now, we're going to go over in class how to be able to do this with like algebra tiles and things like that. But in this case, we're just going to be able to see how to do it on paper so we don't have to spend all that time drawing and doing all that. It's a great way to picture it and what's going on, but here we want to be able to just solve. So what I've done is I've lined up, according to the degree, each term from each expression we're adding together. In other words, I took the third degree and I lined them up just here. I took the second degree terms and I lined them up there. I took the first degree terms and lined them up here. And lastly, I did the 0 degree terms and I lined them up here. Now notice how there's two blanks there. We're going to fill those in without changing the value. The way that I do that is in the 0 term. In other words, in my constant. If I put plus 0 over here, it doesn't change anything. So since it's not changing anything, that's completely valid. Value hasn't changed, but I get that -1 to pair with something or be added or subtracted to something. So we're good there. Now next I see another blank below the first term, or first degree terms. So what I have to do is I have to be able to add 0x, because 0 times anything is 0, so that's the same thing as just writing 0. It's like a placeholder. But now I have 2 x's to the first degree. I can combine those. So as I combine them, I'm going to find that 2x to the third and another x to the third, when I'm adding, means that now I have 3x to the thirds. Now I'm going to take -5 plus a +2, which means we're just combining those. I'm going to end up with a negative, whoa, I clicked the wrong thing, a negative 3x squared. So when I combine my x and my 0x, I got to remember that's the same thing as just 1x. So 1x plus 0 is just 1x, but it's positive because I added it to x. Then I have 0 plus a -1. Adding a negative is the same thing as subtracting, so this is just 0 minus 1. And I get -1. Now I'm going to want to simplify this a little bit. The nice thing is it's already in order. I don't have to worry about an order, but what I do need to worry about really is this guy here. I don't need any leading coefficients of 1. I don't need any terms of 0. So those are the things I'm looking to remove at this point. So I'm going to get 3x cubed minus 3x squared plus x minus 1. And this would actually be the standard form of the sum of those two original expressions. Now, last time I had to do a little bit of rearranging, because notice how I had to take this x to the third and move it to the front so it was in line with the other x to the third. These two are already in line on B, so let's take a look to see what happens here. Here's my second degree monomials. And here's going to be my first degree monomials. And then here is going to be my 0 degree monomials. Now I just add them or subtract them depending on how you want to look at it, but I'm going to combine those together. If I have 3x's and I get, or if I have 3x squared and I get 1 more x squared, I'm going to end up with 4x squared. Now I should go ahead and color coordinate this just like I did before. There. 4x squared. Now notice how I'm not writing plus or I'm not writing minus, because whatever sign is attached to my next answer for the term is what sign I'm going to have, adding or subtracting, because a positive means add, negative means subtract. So I have 1x, then I get 4 more x's. That means I have 5 x's. And then, after realizing I'm dating way too much if I got 5 x's, am I right? We have a -6 and a positive 10. When you bring that together, that's going to be a positive 4. So I have now combined or added all of my like terms, if you want to look at it that way, because that's really all we're doing, is we're adding our like terms like we've been doing for a few years now. And when I did that, I got 4x squareds and 5x's and 4x to the 0.